Okay guys, this is the second class for the MATLAB 2 ME202 for summer 2020. So I asked you a question about in previous class that MATLAB is coming up, and was that, so why if you use ATON or means arctangent or ATON 2, it's gonna give you the same result for the complex numbers in MATLAB. Okay, so let me open all of them. And as you know, I uploaded this on my YouTube channel, and you can go and see it there. So you can introduce to your friends working on company if you want to have the solid and basic foundation in understanding of the MATLAB. Okay, so we are here at page 5, I think, if I'm not wrong. Yeah, here we go. And I make it bigger that we can see it a little. Okay, so the question was, if I have an imaginary number, because I told you we have a magnitude and the phase angle of that. That's right. This is A is equal to, say, 2 minus 3i. That's right. I told you that you can have its magnitude, means A is equal to gonna be 2 plus square and 3 squared, means real squared and the imaginary part is squared. So it's gonna be this number, that's right. And the phase angle, as I talked in the previous class in part 1, it is minus 3 by 2, that's right. So this in the MATLAB gonna be the ABS command, ABS of this, ABS of as I did in the previous class, ABS of SQRT. No, ABS of 2 minus 3i. That's right. And sorry for the noise, because of the pandemic that we owe to a transcribed country, so we have to tolerate that. So, and this is ATON in MATLAB, minus 3 over 2. And I told you if you want to have the proper judgment about the quarter and the unit circle, you have to ATON 2 minus 3 over 2. In the both case, we got minus 556 degree. Remember in the previous class? That's in the YouTube. Okay. So and I taught you about this. I taught about the unit circle. I reminded you from trigonometry. That's right. And where here is the cosine. Here's the sine. Here is what? Come on, guys. You know it's tangent. And the S-plane, I taught you that you're going to see in the vibration and control classes and robotic class. You have a real axis and the imaginary axis. That's right. 1, 2, 3, 1, 2, 3, 1, 2, 3. And I taught you, and I refresh your mind that in the unit circle, the datum of the measurement of the angle is from the cosine axis. Here's positive. Here is negative, if you're counting. So here's pi over 2 minus pi over 2. That's right. Here is pi, and if you go this way, it's minus 5. That's right. So, but when you type ATON or ATONGent as we did, I'm going to do it again in the MATLAB, and you get minus 6 because the number is 2 minus 3i. Its real part is 2. That's right. So it is 2 here, this one, and this is minus 3. Minus 3. So see that here is how much? Minus 56. Yes, here's positive, here's negative. That's right. So on the other hand, where we are, oh, what happened? I intentionally in the previous class plotted the number here to alert you, because this is I plotted here the side. So I said white, but exactly this is the same, right? So you have minus 50, minus 56. So this is this number. This is 2 minus 3i. In the previous class, I plotted for you this number. This is minus 2 minus 3i. Understand? This is correct. Matlab gives you the right number. So let me use Matlab and we see what we have. Atan. So say atan 2 of minus 3 divided by 2. This gives you, minus 3 and 2. This gives you this number, and if you remember, you have to multiply with 180 divided by, give you the angle. And then the other number is this, okay? Is minus 123 minus 123 6.1. So you see that Atan gives you a proper number. And if you look at here, if you look at here, yes, this angle is how much? Minus 123.4, whatever it is, this angle. Understand? This is this angle. So Atan now gives you, you're in the third quarter, but here you are in the fourth quarter. That's right, for this number. For this number, you're in the fourth quarter. This is the third quarter. Understand? So that's what we have. Even that you use Atan only for this number. Let me see. Oh, Atan, you have to use this. This gives you 56 degree, guys. This is wrong. This is wrong. I'm emphasizing several times. This is a wrong number, because this number, if you use Atan or arctangent in Matlab, so this gives you this. This gives you this number. This is plus 56, guys. Plus 56. So that's why when you're dealing with the complex number in Matlab, you have to. It's better that you use Atan 2, means arctangent 2. That is calculating the result with respect to the quarters that we learned from unit circle. Okay, so I intentionally did that in the part 1 to teach you in this class. Okay, now let's continue. Okay, now it's a good time, as you can see here, to assign symbolic parameters to numbers. To do this, we use, for example, a is equal to 2. Say, let me do this. Okay, we say a is 2. Okay, a is 2. That's right. And if I type a gives you 2. Now you can assign a number to a parameter. Why? Because this is good for the coding. When you go to the coding, you're gonna see that. When you go to the upper level courses, like as the control, specifically under robotics, and we have to write your code as a parameters, not as numbers. So practice. So let's do it together. That's right. So a is equal to 2, as we did. See, a gives you 2. B is equal to minus 3. Please do it with me. Okay. So only way after learning is practicing and practicing and practicing. There's no shortcut in this universe. So now, as I defined a as 2 and b as minus 3, now I'm saying that now, because I know what's a and b, say is a plus b. Oh, it is minus 1, because minus 3 plus 2 is minus 1. Now I say d, calculate for me a minus b. It's 5, because 2 minus 3, gonna go 2 plus 3. That's right. 2 minus minus 3 is gonna be plus 3. It's gonna be 5. Now the e I want to calculate as square root of a. So sqrt, now you know the command. That's right. Plus b square, because we already assigned a and b. That's right. So this is gonna be your answer. So you see that when you assign the numbers to the parameters, so you can you can simplify your code. Now f is equal to e to the power of 4 minus d to the power of 3. That's right. Because we already calculated e and d based on the formulas in the previous sections. Now it gives you the answer. Right? So now you can build up your code in MATLAB. Okay? And now k is equal to 2i. See? I say k is 2i. Means what? Means this imaginary number. Or you can say k is equal to 2i. It's gonna give you the same result. Now I'm gonna say k underline 1. This is the best approach that you define your parameters in the code in MATLAB. Underline, okay, is abs of k means absolute value or magnitude of a complex number I taught you in the previous class. That's right, plus c. That's right. Here we go, and we already have c from here. This is c. We calculate. Or k2 is equal to this abs magnitude of k underline 1. That's right. That we calculated here. Power of 3 plus DE4. Let me type like this exactly. Let me see what we have. DE4 has no meaning, guys. That's right. So because you cannot say, because D is a number, you have to do that. So you have to say D multiplied by 1E4. Understand? This is a trick. Understand? So, and here we go. This is the result. So be careful. You cannot put the parameter here, DE4. Okay. See here, I'm just doing here. Upper arrow gives you to D. So we cannot say DE4 because this is syntax error in MATLAB. Okay. So the question is, can we multiply or divide real and imaginary numbers? Yes, that's right. So say I'm assigning, okay, a is 2, okay, and when you put semicolon, it doesn't show again. See, if you say only this, it's showing that. But when you put the semicolon, only saving 2 inside the a. That's right. And the b is AI. That's right. So has no meaning. So you have to say AI. Now it has meaning. That's right. So because this is very different, guys. Different from, see, this shows you this. Understand? Now I'm gonna say B1 is equal to A divided by I. So I is 2. Gives you this. Understand? How we came up with this? Can you guess? All of you? Let me show you. This is mathematics. See? A is 2. And I want to calculate P1. So, guys, so when A is 2, and I ask that MATLAB calculate this for me, A divided by I. So, sorry. So it's 2 divided by I. So you can multiply the numerator and denominator by I. That's right. So this is -1 because it's I squared. This is I squared I taught you is -1 minus 2I. Or it is 0 minus 2I. Its real part is 0 and its imaginary part is 2. So you see that MATLAB does it for you. Okay? MATLAB does it, so you don't need to do by hand. Understand? So this is real mathematics, obviously it is. So it's recording. Okay. Understand? Okay, after the trivial numbers, let's deal with the vectors. Vectors are made of numbers either in rows or columns as follows. It is very important when you're dealing with the different coding, even from the CFD or computational fluid dynamics, vibration, control, robotics, whatever you have to deal even in the mechanics of material. In the high level, you have to do you have the stress tensor. So let me delete that. So now we know that I said A is 1. Gonna give you a scalar number. But in MATLAB, you can use this. A is equal to bracket 1, 3, 4, 5, 10, and minus 4. 10 and minus, exactly like this. See? So it has how many elements? 1, 2, 3, 4, 5, 6. So this is a row of numbers, that's right. It has one row and how many columns? 1, 2, 3, 4, 5, 6. This is how we generate vectors in MATLAB. Okay, see, this is a vector of A. Understand? Now let me generate a column in MATLAB. -4, 2, 8, 3. If so, this transpose. So you see, I'm working on this. This transpose. This T stands for transpose of a vector. Vectors are essential components of not only mechanical engineering, but also other fields like physics. Okay, so but let me try it. If I write here transpose, let's see what they're gonna give us. Obviously error. It says that are you out of your mind? Okay, so transpose in MATLAB must be written like this. You can just close to the enter. That's right. Look at your keyboard. So if you do that, it generates you a column. That's right. One column, how many rows? 1, 2, 3, 4. So again, I'm running for you. Your A is a row, and your B is a column. So you see differences. That's right. This is row. This is column. Okay. Now let's go to this part. C. So your C is 1, 0, 0, 0. You can have a column of C like this I'm doing for you. This is a column of C. You can have a row of C. That's right. It depends on the application and the coding that you're gonna have. Okay. We're gonna go there when we solving the differential equation eventually. As we had the summation of the scalars, we have the summation of the vectors. So let us add vectors A and B mentioned by MATLAB through the following commands. So again, you don't need to type it exactly like, because already I did it. Just push the upper arrow. See? So this is A that we already typed. Enter gives you this. And now B. Right? So this is B. Right? -4 times. Now if I say C is equal to A plus B, what do you expect to see? I give you 2 minutes. Don't go forward because we are learning, okay? This is from trivial algebra. So what do you expect to see? 2 minutes. Think about this. We define the vector of A, we define the vector of B. What do you expect to see? Enter. Oh, error message. Matrix dimensions must agree. That's right. Matrix dimensions must agree. So why? Because see, the size of vector A is 1, 2, 3, 4, 5, 6. Has 6 columns, but B has how many columns? 1, 2, 3, 4. You cannot add apple with peach. They must have to have, yes, equal columns. That's right. That's why MATLAB says, hey, wake up. Matrix dimensions must agree. If doesn't, bye-bye. So, matrix dimensions, why? Simple. The dimension of vector are not equal. The dimension of A is 1 by 4 and 1 by 6. Dimension of B is how much? 1 by 4. So how we do that? just use the following command in MATLAB. Okay, let's do that. Let me delete everything. Here A was this. If I see D is size, this is a command in MATLAB. Size of a given vector or matrix that you're going to see eventually. It gives you the first number is the number of the rows. Size means go and find the size of a vector or matrix. 1 row, 6 columns. Understand? Now if I say B and say E is equal to size of B, what do you expect to see? You see 1 and 4. So you cannot add a vector that has dimension of 1 and 4 and vector has dimension of 1 and 6. So right, this is ridiculous. So the first column of size command indicates the number of row of a vector, while the second column stands for the number of column of vector. Right? So as enhanced dimension are not equal, and we cannot add the vectors. Okay. Now, before going ahead and before going to this, now let me again show you vector A, because it's not in the notes. Another command you can say A is length of A. Oh, sorry, I have a typo. Oh, HNT. So length of A, it's gonna be 6. Means that A has 6 columns. Length. Okay, length command in MATLAB, it gives you the number of the columns. Or if I say B again, for refreshing your mind, and if I see, now find me the length of the B, length of the vector of B, length, the number of the columns of that, so it's gonna give me 4, because it has 4 columns. Now if I say this is your B, I make it column. Now if I say length of B, it's going to count again the number of the rows. So the length is very good tool that gives you the number of the columns or rows of a vector. I'm talking about a vector still, not about talking about the matrix. That's right. Vector is subset of a matrix. Okay. So it doesn't matter that you're dealing with the rows or you are dealing with the columns. So the length gives you the size of that. Or for another example, if your A is this, now I make it vector, and if I say length of A, the number gonna expect is that 1, 2, 3, 4, 5, 6. Bingo. Gives you that. Okay, now, but we understand, okay, for refresher in mind, we understand that if A is this and the B is this, you cannot have A plus B because the dimension are the same. Now, let us type this command. C is equal to, now, first modify this, make the B as a column. Now, what to expect to see now? Bingo. You're gonna see a matrix. Understand what I'm talking about? See, 1 minus 4 is minus 3. That's right. 1 plus 2 is 3. 1 plus 8 is 9. 1 plus 3 is 4. So 3 minus 4, where we are? Okay, sorry. Yeah, okay, and you can continue like this. Okay, so let me double check about the A. So you see that if you add a vector and a column, right? Okay. Oh, you're A. I see that. Why there is the guys? Sorry. Here, this is another A. 1, 3, 4, 5, 10, and minus 4. Okay, I see that. Why not more than that? 1, 3, 4, 5, 10 with another A. And your B is another B. Here I type in the notes. I thought they are the same that I already defined. Is minus 4, 2, 8, and 3. That's right. Now if I say C plus A, see? Minus 3, 3, 9, 4, minus 1, 5, 11, 6. So you see that the take-home message is that, as we know from algebra, guys, if I add a vector of 1, 0, 2, 3 plus a column of 0, 3, 5, okay, first of all, let me teach you first of all this one back here. First of all, MATLAB do that for us. So you see that matrix A length is how much? 6. This is 4. So you're gonna have a matrix of 4 rows and 6 what? Columns. This is algebra. That's right. See? This is 4 rows but 6 columns because it has 6 columns and 4 rows. That's right. Here we go. 6 columns and 4 rows. Now, if I do another example, if I do this, this has how many rows? 4. This is 1 by 4. Sorry, 4 columns, and how many rows? 3 by 1. So what to expect have? You have to expect a matrix of 4 columns and how many rows? 3. How? This is 1. This is 3 rows per column. So yeah. So this is 1. So I want to see just okay. So this is so this is 1. Okay. This is guys, I confused. Okay, guys, it was noise here. So it is 1, and it is 4, and it is 6. Now 0, 3, 5, 2, 5, 7, and 3, 6, and 8. 1, 4, 6, 0, 3, 5, 2, 5, 7, and so you have 3 by 4 what matrix. If you do that in the MATLAB, so your A is how much? 1, 0, 2, 3. Oops, 1, 2, 1, 0, 2, 3. 1, 0, 2, 3, and your B is 0, 3, 5 is 0, 3, 5. Oops, sorry. This column. So C is equal to A plus B exactly is that we calculated here. See here. So here we go. Okay. So it's very perfect from algebra, that's right. So and now you see that, okay. But if you have two rows or two columns but dimension they are not the same, syntax error. Okay. The result is a 4x6 matrix. Note that this is a transpose vector again. A is a 1x6 vector and B is a 4x1, 4x1, and therefore A plus will be a what? A 4x6 matrix, 4 rows and 6 columns. Okay. Now, as practice, please do this practice 4. So add the following vectors together, okay, and discuss the results. Okay. So this is the second class, and we are done until third class. So again, for clarifying, in the part 1, I give you a tricking point, and I plotted the imaginary number in the wrong side of the real axis to discuss the artan and artan 2. So be very careful when you're dealing with imaginary number. You have to use artan 2 or arctangent 2 command. I'm emphasizing it, guys. Artan 2. Artan 2. Okay? Please do that. Okay? Again, artan 2 is the imaginary part and the A part. Bingo. Actually, we don't have A and B, but I mean that. Okay. So, see you on the next class.